Credential dumping, 5 SIEMs, 1 Sigma rule. Credential dumping is the second most observed technique in real-world breaches, according to Red Canary's 2025 threat report. 86% of ransomware attacks involve credential theft before the encryption payload runs. Attackers need credentials to move laterally, escalate privileges, and maintain persistence. If you can catch them stealing credentials, you stop the breach before it gets expensive. MITRE ATT&CK T1003 covers OS credential dumping with several sub-techniques. The most common is T1003.001, LSASS memory access. LSASS is the Local Security Authority Subsystem Service. It holds credential material in memory. Tools like Mimikatz, ProcDump, and Task Manager all access LSASS, but attackers access it with specific memory permissions that legitimate processors rarely need. That's your detection signal. Here's the Sigma rule. We're using the process access log source, which maps to Sysmin Event ID 10. The detection targets any process opening a handle to LSASS with one of 3 granted access masks: 0sen-sen, 0som4-sen, or 0x1438. These are the permission combinations that credential dumping tools request to read process memory. Legitimate LSASS access from AV and EDR tools uses different access masks. This rule is flagged as experimental, level high, and mapped to the credential access tactic and T1003.001. 1 Sigma rule. Now let me show you what this looks like in all 5 SIEMs. In Splunk SPL, we query the Sysmin index for event code 10. That's the process access event. Filter to LSASS as the target image and match on any of our 3 access masks. Pipe to table to surface the fields that matter: time, computer, source process, and granted access. In Elastic KQL, the structure is similar, but field names follow the Elastic common schema. We reference winlog.event data fields for the Sysmin data. Both rules detect the same behavior: a process requesting dangerous access to LSASS memory. In Microsoft Sentinel KQL, we query the security event table, filter on event ID 10, and use the ends with and in operators for the LSASS match and access mask check. Sentinel's KQL is expressive and readable, very similar to Elastic but with slightly different table names and operators. For Wazuh, we write a custom XML rule. The rule ID must be in the 100,000 to 99999 range for custom rules. We reference the Sysmin rule group and match on the target image field containing LSASS.exe. Level 12 maps to a high severity alert in Wazuh's alerting system. 1 detection concept, 5 implementations. This is why I recommend learning Sigma first. It forces you to understand the core logic before the platform-specific syntax. Before you deploy this rule, tune it. Antivirus and EDR agents legitimately access LSASS, but they do so from predictable paths: your AV vendor's installation directory, your EDR agent path. Filter those out by source image. Windows itself has werfault.exe and Task Manager accessing LSASS, but again with different access masks. Access mask 0x1000 alone is benign. Process Explorer uses it for display purposes. The masks we're targeting, 0x10, 0x1410, 0x1438, are the ones used for memory reading operations. A tuned version of this rule should fire once per actual credential dumping attempt, not 500 times a day on normal AV activity. Take the time to baseline your environment before you push to production. If you want to test this detection right now, SOC AI has a credential dumping lab scenario with real LSASS process access logs. You pick your CM, the AI walks you through building the detection rules step by step. 5 SIEM platforms, 55 attack scenarios, 5 free queries per day, no account required. Link is in the description at socai.app. Subscribe for more weekly detection engineering content. I publish every Monday and Friday for long form and shorts throughout the week. Drop your SIEM in the comments, and I'll see you Monday.